Day 21, 80% of the way through for the year. Alright. Here's the puzzle input. What do you get if you multiply the score of the losing player by the number of times the die was rolled during the game? Okay. How much did... Single die, 2 pawns, and a game board with a circular track consisting of 10 spaces marked 1 through 10 clockwise. Each player's starting place is chosen randomly. Player 1 goes first. Players take turn moving. Each player's turn. Player rolls a die 3 times, adds up the results, and the player moves their pawn that many times forward around the track. If the player is on space 7, they roll 2, 2, 1. They would move forward 5 times. 8, 9, 10, 1, 2. After each player moves, they increase their score by the value of the space their pawn is on. Player's score starts at 0. If the first player starts on 7 and rolls a total of 5, they would stop on 2 and add 2 to their score. Game immediately ends as a win for any player whose score reaches at least 1,000. This first game is a practice game. Submarine opens a compartment labeled deterministic dice, and a 100-sided die falls out. So this is our sample data. All right, that's the theory. Okay, cut that out. That's our sample data. It was 1, 2, 3 for 10, 4, 5, 6 for 3, 7, 8, 9, blah, 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 blah. Okay, so player 1 has rolled at least 1,000 points. Player 1 wins and the game ends. At this point, the losing player had 745 points, and the die had to be rolled a total of 993 times. Play a practice game using the deterministic one-sided die. The moment either player wins, what do you get when you multiply? Okay, so here's our puzzle input is 10 and 2. We'll go ahead and run it with the sample input, though. Okay. Player 1 position is, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 28. And parse data 0, 28. Player 2 position is the same thing, int parse data 1, 28. Okay, so we need to roll the dice. All right, so the die starts on, we'll say it starts on 0. Last roll is 0. Every player, let's see, we had to count, so roll count we need, right? Let's see, turn, let's do this. Players is a new, okay, so the turn is going to be 0. While true, player is players of the turn. Whose turn is it? All right. And then rolls is roll, given the last roll, plus roll. Let's do it like this. 0, index is less than 3. Roll is roll die, last roll. So the last roll is going to be equal to the roll. Increment is going to be, we'll start with 0. Increment plus equals the roll. We'll do that 3 times. Then, let's see, so the new space is player's current space plus the increment. All right, and we'll just say round space, right? let's see, player spaces. All right, and we'll do player scores. There's a new int array of the player spaces length. And it's fine that everybody starts at 0. Player spaces constant values expected. Fine. All right, so we'll roll the die. And then we round the space. The player scores of whoever's turn it is, plus equals the new space. If player scores sub turn is greater than or equal to 1,000, then we break. The loser is 1 minus the turn. We are going to return player scores of the loser multiplied by the roll count, which we never incremented. Roll count plus plus. Right, that is what it is. Multiply the score of the losing player by the number of times the die was rolled. Yep. Okay, so we need then int roll die, int last roll. Result is last roll plus 1. If last roll is greater than 100, then last roll minus equals 100. We can even do while here because I feel like we're going to end up reusing this. Return the result. Okay, and then we need to round the space. Same thing, round the space. While space is greater than 10, space minus equals 10, return the space. Okay. Player plus increment. Player plus increment. Why did I type increment there? Player. Oh, yeah, that's right. Player plus increment. Yeah, you don't need to be long. That's what the problem was. Okay. So this should give us apparently 0. Why? Okay, so our spaces are 4 and 8. That's what we expected, right? Our scores are obviously 0 and 0. So while true, oh, yeah, we need to set the space again, right? Player spaces sub turn is the new space. Oh, no, not plus equals. Why did I do plus equals? That makes no sense. What we wanted, though, is player scores at the turn plus equals the new space. That's what was plus equals. Okay. Why? Oh. Turn player scores of the loser. Fine, whatever. We obviously break out of here, right? So the loser is going to be 1. Player scores are 1,000 and 0. Why did you end up with 0? That makes no sense. Oh, because we never changed the turn. Turn is 1 minus turn. Sure. 739,785. 739,785. Okay, now we take our real input, which is 10 and 2. Throw that in there and get still a fairly large number. Right, and then say go. It's good. Okay, now that you're warmed up, it's time to play the real game. Second compartment opens, this time with D-Rack dice. Out of it falls a single 3-sided die. As you experiment with the die, you feel a little strange. An informational brochure is a quantum die. When you roll it, the universe splits into multiple copies, one copy for each possible outcome of the die. In this case, rolling the die always splits the universe into 3 copies. One where the outcome was 1, one where the outcome was 2, and one where the outcome was 3. The game is played the same as before, although to prevent things from getting too far out of hand, the game now ends when either player reaches 21. Using certain starting positions as player 1 wins in so many universes, player 2 wins in so many universes. Using your given starting positions, determine every possible outcome. Find the player that wins in more universes. In how many universes does that player win? Okay. All right. Now I am being dumb, and I lost my... Oh yeah, there's my puzzle input. Cute. Obviously, given the numbers that we're looking at here, right? That's a pretty big number. Right? That's a pretty big number. We obviously can't keep track of the entirety of every possible outcome. But we know that, like, the dice rolls look like this, right? And then obviously that gets duplicated. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 27 possible outcomes. All right. 27 possible outcomes. So this is 3, 4, 5, 4, 5, 6, 5, 6, 7. All right, and then this all goes up again. So we have 1, 3. Here we have 2 4s. And here we have 3 5s. All right, and we have 2 6s. 7. We have 1s. We have more outcomes here. So we'll talk about 0 times here, and 0 times here, and then we have 1, 2, 3, 2, 1, 0, right? And then 0, 0, 1, 2, 3, 2, 1. So that's 3, 1, 3, 6, 8. All right, 3, 5, so now 7. 3, 5, 7. 6, 3, 1. Okay. So we actually only have 4 outcomes, but we have some of them twice. All right. So we have that once. Make sure I did all this right. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. 1, 3, 6, 3, 5, 7. 6, 3, 1. Okay, that looks good. So those are the things we know. We have Whoops. Yes, you can get 3 twice, you can get 4 twice, you can get 5. Sorry. No, totals. Yeah, no. 3 twice. You can get 4 6 times, right? Because 3 times 2. You can get 5 12 times. You can get 6 7 times, right? Oh, wait a minute. I don't know why I did this. This is dumb. Never mind. Never mind this. This is just being dumb. I'm being dumb. Ignore me. So you get 3 once, you get 4 3 times, you get 5 6 times, you get 6 7 times, you get 7 6 times. I don't know why I was trying to collapse things. I'm trying to make the problem easier, but that's not making it easier. So that's your distribution of rolls. There are actually 7 rolls. But that still seems like it's too many times to run them all. Right? Like I think what you do is you don't actually have 27 universes, right? You have essentially 7 universes. Is that right? But still, trying to get to 21 is going to take a while. And it is kind of like a multiplication problem, isn't it? It's like I determine the score, and it's like I'm keeping track of how many times that score is going to come up. So if I were to take 10, what I really want to know is, given our starting numbers, right? Like I don't need to roll everyone against everyone. What I can do is I can say, given each starting number, how many... Well, shit. There's definitely a way to do this that's just going to be just like a straight up math solution. I'm just trying to figure out what it is without having to roll 444 trillion times. These two numbers... Well, why did I do Notepad? I want a calculator. Plus this number, right? Let's copy that and throw that into the Notepad. Because I want to see that in hex. Will you show it to me in hex? Nothing obvious in that from a hex perspective, or an octal perspective, or even a binary perspective. So what is 13, 16, 17, 9, 10, 27. So that was right, 27. So what is 1 to the 27th, or 1/27th? Let's store that. Let's take this number to the power of that. Oh, well, that doesn't help me. Well, that's not ringing any bells. Okay. What if I... Okay. So but here's what I'm thinking. I'm thinking that if I can take the two spaces, and I can basically determine how many times we get a particular score, right? Like how many rolls does it take me to get to 21? And these, if I know that these are the 7 possible values I can get out of the roll, right? I can basically run it over each one of those and keep a dictionary that is a count of how many universes are in which space. That might work, right? Because if I can find out like how many rolls it takes to reach 21 in how many universes. So the score, so what I want to keep track of is, I think I need to keep track of the roll count, the score, and the universe count in which that's true. Right? So let's do this. Let's do roll frequency. Let's call it that. There's a new list of int. Right? Why don't I have a list? Okay, there's a new list of int. So this is going to be 3, 1. So this will be int roll. And then int frequency. 3, 1, we have 4, 3, we have 5, 6, we have 6, 7, we have 7, 6, we have 8, 3, and we have 9, 1. Okay. And what we want to keep track of is a roll count, a score, and a universe count. Because I want to keep track of how long does it take me to get to 21, right? So let's just try. Let's start with a score of 0. And now we have a roll count, a score, and a universe count. What is the best way to do this? Do we... Yeah, so we need a roll count. We do have to do this in parallel, though, right? Or do we? They are kind of independent, aren't they? Okay. So I think what I need is... I'm trying to think of the best way to index this so it doesn't explode. What if it's indexed by score? All right. Let's say foo by score. I don't know what to call this. What if you were a dictionary of int to a list of no. And there's something here that I'm just not like I think I'm close. I also need to know what space they're on, right? Maybe that's what it's indexed by. This is where not having a math degree always hurts me in these things. Somebody is out there going, it's just a blah. If only you knew. All right, so let's walk through this once, right? So if I'm on, let's not do it here. Let's do it in NumPy. Okay, so let's say I'm on space 1, right? My next move basically says I'm on space 4 with a score of 4. I'm on space 4, score 4, roll count 3, universe count 1. Space 5, score 5, roll count 3, universe count 1. No, universe count 3. Space 6, score 6, roll count 3, universe count 6. Space 7, score count 7, roll count 3, universe count 7. Space 8, score 8, roll count, that wasn't 3, this is supposed to be 6, roll count 7, universe count, sorry, roll count 3, that was my bad, roll count 3, 1, 3, 6, 7, 6, because we're doing 7, space 9, score 9, roll count 3, universe count 3, space 10, score 10, roll count 3, universe count 1. So then for each of these, I just have to do that again. This gives me 7 each time. Like, how explosive is that? I don't know. Maybe I'll just try it. Let's see. Space. Score. Rolls. Universes. Right. And we'll start with here is we're on, I don't know what space it's supposed to be. Let's say space 4, because that's one of the starting ones. But a score of 0 and no 0 and 1 universe. Okay. Wow. While there are any rolls to look at, we'll do a finishes. Is going to be the same thing. And you'll be empty. Actually, I don't care about what space you're on anymore. Just want scores and rolls and universes. Okay, so while we have rolls, for each roll and rolls, we're going to make a new rolls list. Oh, that was more than I want to copy. So for every roll in our existing roll list, we're going to do something, and then rolls is equal to the new rolls. All right, new rolls. Every one of these we're gonna do this, which is for each roll frequency in roll frequency. All right, we're gonna then say your new space is round the space of your current space. And we're going to add the roll frequency roll, right? Your new score is roll score plus the new space. And then new universes is roll universes times the roll frequency. And then, of course, the new rolls is roll rolls plus 3. New roll count. Okay. If the new score is greater than or equal to 21, then we're going to put you in the finished list. All right, and for the finished list, we need the new score, the new roll count, and the new universes. Otherwise, we're going to put you back into the new rolls list. New rolls, add, and then you're the new space, the new score, the new roll count, and the new universes. So let's run this once. I don't care about you. I definitely don't care about you. Okay. So given our existing rolls are you're on space 4, right, with no score and no roll count and a single universe. Our new rolls will put you in 7, 8, 9, 10, 1, 2, 3 with 1, 3, 6, 7, 6, 3, 1. And those are your scores. All right, so let's do that again. So in our new rolls, we should get 49. We're getting people up towards 21, but not quite there. Now we're at 272, but how big is our finishes list? We got 71 finishers already. So there's our finishers. So we got a lot of finishers, but I kind of feel like well, the roll count does matter. The number of universes does matter. But this is exploding way too much. Yeah, this is exploding way too much. So on the finisher side, then maybe what we really need is we really need a dictionary whose key is score and rolls and whose value is long. Okay. And so here on the finishers side, finishes, try get non-enumerated count. That's great. So try get value. Not finishes, try get value. Let's see. We have new score, new roll count. Out var universe count. This probably needs to be up here. Out universe count. So if we can't, actually, that's okay. We'll take 0. 0's fine. Finishes, this is our key, so let's go ahead and put that here. Key is that, so the finishes of key is universe count plus new universes. Okay, so let's see if that explodes less. So let's look at finishes. There's no finishes yet. None, none. We get 7 finishes. So 21 and 9 has happened 1,181 times. Yeah, our finishes count is much more reasonable now. Okay. So if I look at the finishes count, there are a bunch of universes in which we get to winning values with a specific number of rolls. So I think I need to do this for both players, right? So let's call this player 1 is get finishes for player spaces sub 0. Player 2 is get the finishes, get finishes for player spaces sub 1. We don't override player spaces, we do override player spaces. Yeah, that's bad. That's fine. We'll just read it in twice, not a big deal. Okay, so this is get finishes. I'll copy paste the type in a second. Get finishes int starting space. And you're going to return this. All right. Turn to finishes. So that didn't take very long. So there are 1,181 universes in which player 1 finished in 9 rolls. My guess is that because player 1 goes first, right? It doesn't matter how many times. Oh, well, that's interesting. 1181, 1058, 943, 712, 478, 180, 187, 49. 24, 724? Are you kidding me? That can't be right. They start in different spaces, right? Oh, yeah, we forgot to use the starting space. Thank you. All right, so there's player 1. There's player 2. So I think what we want to do is for each one of these, what I want to say is for each score, probably need to look this up by score. All right, so the finishes. What we really want to do is we want to transform this. We want to say to dictionary. Right. So for a given score, we want to know we want to say for a given score, yeah, I don't think I can do this with link. Okay. So the result is going to be a new dictionary of int to, yes, you can stop. New dictionary of int to int space long universes. But I think I need this to be a list of these. Or maybe it's a double dictionary. For each var item in finishes. All right, we're going to do result try get value for item key score. Dictionary. So if not, so we're going to say dictionary and long dict. So if not that, then a dictionary is just a new dictionary. Right. Wording null, literal dict is not null. You have to be a real actual dictionary. That doesn't sound right. Okay, yeah, sure. You're going to tell me I can do out var? Is that what you're going to tell me? Yeah, okay. That's fine. Dict is still available here, right? Okay, good. I should be able to say dict try get value of item dot finish it, item dot key dot roles out var universes, right? And then we'll say dict of item key roles universes plus item dot value dot item dot value, right? Because it finishes where a universe count. So return the result. So this is our new return value. Oh yeah, you have to go into the dictionary. Result, some item key score is the dictionary. Thank you. How come escape doesn't work here? Okay. So 1181 times we got it in 9 rolls, 12 rolls, 15 rolls. So I think what this means is we win because player 1 goes first. Every time that we have one of these rolls, right, player 2 loses. Right, so what's the maximum roll count? Player 1 dot max of all right, those are the rolls. So the maximum roll count is 30. And the maximum roll count is 30. So then what we should be able to do is we should be able to say index is 9, index is less than or equal to 30. We should be able to say player 1 wins is 0L, player 2 wins is 0L. All right, so in any given let's see. Let me see if I can verbalize this. So for sure, every time 9 is rolled here, we're looking to see if anybody can get less than us. So nobody can get less than us. Right, so we'll say player 1 see, player 1 win. See, total wins. So player 1 wins is going to be player 1 of index Wait a minute. I actually don't care about the score, do I? All I care about is how many times you got there. I actually don't care about the score. I just want to know how many times you won and how many rolls. Right? So it's really just this interdictionary. Yeah, that's it. And I don't need any of this transformation stuff. So sorry, new roll count. So let me take a quick screenshot of this because I want to see. I'm going to throw that over to the side. All right, this is starting to look good. So 4,608 times we won in 9 rolls. Let's just see if we can get to player 1 win total. Let's not worry about player 2 yet. All right. So the player 1 win is going to be player 1 index. And then we'll say index 2 is index minus 3, index greater than or equal to 9, double minus index, let's see, no, index 2 minus equals 3. This, by the way, this was supposed to be plus equals 3, right? We want to count backwards and say player 1 wins. We subtract the number of times that player 2 wins with fewer rolls. Right? Are we running here? We're index is index minus 3, while the index 2 is greater than 9. Thank you. Okay, so the player 1... Oh, and we forgot to add them together. Player 1 total wins plus equals the player 1 wins. All right? And we're stopped, and so our total wins... what is a long max value? A lot bigger than that. All right, this is bad math then. What am I doing wrong here? Let's look at the finishes. Let's see if I can understand exactly what's going on here. So let's do watch. Let's do player 1 sub 9. Don't care. Player 2 sub 9. Actually, just show me player 1 and player 2. It's fine. So 4,608 times, you win with 9 rolls. You win with 12 rolls, so this number needs to be minus this number. Because if you get to 21 before I do, then I can't win that. That seems reasonable, so why did we end up negative? Let's see if we can figure that out. Alright, so player 1 wins is now 4608. That makes sense. Index 2 is going to be 6, which means we don't go through, so there's 4608. So now we're on 12. So there's 249,000. So we go back to 9. Right? And then we say, let's see, so player 1 wins, total wins. Player 1 wins. Player 2, oh, we're looking at the wrong player 2. Index 2. Okay. Think this is going to work now? Player 2, index 2. Alright, so there's our 4608. There's our 250,000 minus 1730. Okay. So there's 321,000, 3 million. So minus 230,000 minus 1,730. Okay. Let's stop down here. I still end up with a negative number. God bless diagnostic tools. I gotta uninstall that piece of shit. Why do I end up with a negative number? There's something going on here that I don't understand. It's got to be... Yeah, see that? Man. I mean, when I look at those numbers on player 1 and player 2, I mean, it's got to be going negative here because at 30 rolls, I lose to all the times when... Except I'm not up against him all those times, am I? Oh. I mean, my math is wrong, but I don't know why. That's nowhere near big enough. Yeah, that's nowhere near big enough. There's a multiplication factor that I'm missing somewhere here. Yeah, there's definitely a multiplication factor I'm missing here. Is it just, do I need to be multiplying these? Like 1,730 universes I finished in 9. 4,608 universes I finished in 9. 4,608 different times I finished by 9. So is it a case of all of these times these times he loses? Or I win? Right? Maybe that's what it is. So you're going to go through +3. We're going to start there. And we're going to multiply by player 2 index 2. What does that number look like? Ooh, 472,851. No. Starting to look like it's the right length, though, right? I don't know why I copied that twice. So those are the real numbers. What's the number I just came up with? Too many. Way too many. Way too many. Oh. Actually, you should start at 1 and you should go there. What's your problem then? Oh yeah, long. Is that better? No, that's also the wrong number. Wow, you're negative? Yeah, I don't know what it is. I'm at a bit of a loss. There's a math formula here that I don't know. Anyway, I don't have any ideas, so I'm going to go ahead and end the stream. Maybe I'll come up with something, but maybe this is my first fail. I don't know. We'll see.